Very good morning to everyone. Warm welcome to all present in the class today. Good morning, good afternoon, and good evening. Good morning. So, today we shall start the journey of microservices. All right. And the prerequisite to understand microservices is you should be very much familiar with Spring Core, Data JPA, and Spring RESTful services. If you know this, then easily microservices can be understood. Fine. So this is a very, very important topic. And these days, most of the companies expect you to know about the microservices. Are you there, everyone? If you say yourself as a developer, you must know about the microservices, and they are very, very important. Now, as a developer, what you should be knowing it, which concept you should be learning it under the umbrella of microservices. First itself, I'll give you an idea, and then we shall go ahead and understand them one by one from the absolute scratch. Okay. In this class, there is a mixture of crowd. The crowd who might already know microservices, they might have already exposed to it by working in some of the projects they have worked, and there is a crowd who are from absolute zero background, who have no idea, from non-technical background or from the university background. Everyone will be in a position to understand what exactly it is. Okay, there are some important things which you must be knowing it under the umbrella. I would like to list out here, and one by one we shall try to understand here from the scratch. I have no expectation, just to highlight. If you say that I know microservices, what are the topics which are must to you? You should know about API gateway, which is must to you. Okay, which is for the filtration, routing. Okay, you should be knowing about service registry, the terms which you must be well aware of, their purpose and how to work with this. For the Spring Boot developer, we have something called as Eureka server. What exactly it is, I will talk. You need not worry, especially if you are from absolute, uh, beginner background. You must be knowing about admin server. You must be knowing about Zipkin server. Then you must know about Spring Cloud config server. Config server. And you should be also knowing about Fiend client. Okay. Apache Kafka. Redis server. How to make your application resilient. Circuit breaker pattern. And retry pattern. Making the application resilient. Okay. If you say that I could able to understand in the process, by default you'll understand the associated concept of load balancing, how automatically you know load balancing happens using the This is default things. We will talk about many things in the process. Okay, many things are there which will understand by default under this umbrella. But these topics is like, if you say I am aware of microservices, these things is something like which you must be knowing it. You should be aware of all these things, right? And again, microservice, it's not something that there is a fixed architecture that everything will be used in every project. In general, as a developer, you should be aware of these important concept as a developer of microservices. Fine, dear friends, all of you. Now, one by one, we need to understand all the applications which we have developed so far. All the applications which are developed so far, they are monolith application. That means we have followed monolith architecture. What is the monolith architecture and what is the problem here? We need to understand here. And I'll be adding these key points from the starting only. Other points I could not add and I have to give you, it is pending on my head. Within this week, all the notes will be given. Microservices, let's understand from the day one itself. Now, can anyone tell me in the class what do you refer by monolith application? Tightly coupled. Whatever terms you might come across under the radar of monolith, you can just say. Like the way Rajat Patil says, tightly coupled. Guys, such architecture which we have developed, right, where all the functionalities of an application, all the features of our applications are developed and packaged into single project. So far, everything whatever we have done in our classes, don't you think it is a single package, single application? All the functionalities as the one application. Design where all the functionalities of an applications are developed and packaged into a single project. Assume that there is a booking.com, one of the application where multiple functionalities are there, no? Booking a hotels, booking a flight ticket, booking a railways, booking a cab. Many things are there and we don't know what architecture they have followed. Seems like it is a microservice architecture, but however, imagine everything is developed as one application. That is only called as a monolith architecture. And whatever we have done so far, okay, and all of that will be packaged into jar or var project and that will be deployed into the server as the one particular application. What is the jar or var file we have discussed in our classes earlier also. Fine. That means at the end of the day, we will be creating a var of our project where all the project files will be there. All the configuration files, front-end files, back-end files, everything into one file that will be deployed into the server. That means our application is live to the world. Our application is in the production, live to the entire world. If all the files, backend, entire features, functionalities of an application is packaged as single project, that we call it as monolith. And right now, whatever projects we have developed, we have done as a one thing, all the functionalities as a one project, and we used to deploy it. There are some advantages, benefits associated with this. There are some pros associated with this. What are those advantages? If someone can make a guess that what benefits will get if you go with monolith architecture? Any idea, guys? Any benefits which is there in your mind? If you guys are there, easy to maintain, great. everything is present inside in one particular place. That means you as a developer will have a big picture about the project. Usually if there is a larger application, a microservice application, you as a developer only will not have a clarity of all the functionalities. You will be focusing on one functionality. Example, if there is a big banking application, sometimes you'll be working on one feature and stuck in that feature for 1 2 year to maintain that feature, to add new things, to delete something, to do something, wherein there are so many features in the entire application and you are not even aware what is happening if they have followed the microservices. But here you will have that idea which will help you to manage easily. Less complexity, simple testing, and single configuration. You will not be having multiple configuration file because it is deployed as one application. It will be treated as one application, right? High availability. You can say that, Anil Tripathi. Very high availability. All these things comes under the benefits of developing the application by following the monolith architecture. By following the monolith architecture, which you can see here, all the key points now itself I'm adding. Simple to develop, which is easy to start the develop, and you can easily initiate the development. All the functionalities are in single project, making it easy to manage, and a single configuration, no need to for the multiple configurations for different parts of the application, because all the parts, all the functionalities will be treated as the one application. Fine, easy to manage, not the maintain. Rajat Patil, you can manage the functionalities easily, but not the maintenance here. Because as the project grows bigger and bigger, then if something goes wrong, lot of problem will be there. Complex to maintain such a big functionality application if it is deployed as one application. Okay. What are the problems, if you guys could able to tell me? What problems will be there if you have developed all the applications as one application? If the small change has to be made, then the whole application has to be redeployed. Wonderful. Scalability issue, great. Tight coupling, great. Deployment would be complicated, great. Scaling problem, great. And all the units will be affected in case of any issue. Single point of failure, we say. Sandhya, great. That's a single point of failure. Wonderful, right? So first of all, it is very difficult to maintain as the features gets increased. Tight dependencies, components will be by default tightly coupled, making it harder to modify or scale, as you guys are telling. Single point of failure, a failure in one part of the system, there is a high possibility that that can break down the entire application because of the dependencies. And small feature change in the code, in the backend, one small code update is there, then you have to repackage your application, then you have to redeploy the entire application, and the downtime of the application will be increased by default for the end users, right? See, if some of the applications are asking you, especially the banking application, keep on, you'll get the message that application will go on to the functionalities. Some of the application says that the entire application will not be available for 20 minutes. Why? Because they are redeploying. Some cases they will say that one functionality, credit card functionality, the small functionality will not be available for 20 minutes. That means they have followed the microservices and only one feature is getting affected for some time because they are redeploying it. And if they are telling that the entire application will be affected for some time, that means they have followed the monolith architecture. Somewhere small changes they have done, then they have to repackage the entire application and they have to redeploy the entire application. Code changes impacts the other functionalities. Great. Great. All of you are at the right place here. Oh shit. See here. This is called as monolith architecture, single point of failure. Have you seen the practical single point of failure here? Everyone in the class. Undo only have done, because of which it is gone. Because of the undo only it has gone. Anyway, same points I have done for multiple batches, so not an issue. I do have some points. Okay. Are you all there? Great. All right. We were talking about single point of failures. So here also single point of failure only happened. Okay. They are very simplified terms, guys, and which will be helpful for you for the quick revisions whenever you want to just would like to revise, because you might not know, right, what is being followed in your applications. Like once you are into the company, you have prepared really well for the interview, and the moment you are excited for a new company, you got into this and you're excited to work on this, and your manager says that you know they are following monolith architecture, and he says so many problems which are associated to the microservices, and it's a new job, and you'll not say no. You'll agree with your manager and you'll start working on monolith architecture, normal old fashion, again for a longer period of time. After 6 months, 1 year, again if you're switching, then again they're in the microservices, again you have to relearn everything. Again it is a debate that which is good and which is bad. You and I cannot just directly say, oh, there is advantage here, there is disadvantage here. We have to see the perspective in many ends. Okay. If I am telling something bad about monolith, there are something which is good about monolith also. Whenever we talk about technologies, we cannot just give a favor only on one thing. If there are something good, there will be something which is not so good also. Okay. Yeah. Difficult to maintain. As the project grows, maintaining it becomes very, very challenging. Tight dependencies, which you guys have only told, components are tightly coupled, making it harder to modify or scale, which is the issue of scaling also. Single point of failure, a failure in one part of the application can bring down the entire application. And the full project redeployment, one of the major issues. Any small change requires, you will be rechanging the code, right? That means a rebuilding and redeployment is needed. And the downtime of the application will be higher here. And that's where what comes into picture? That's where the concept of microservices comes into picture. What happens in the microservices, if you ask me? Where one application will be divided into multiple applications. For every feature, every major feature, you will develop a new application. First of all, guys, whatever the term microservice is there, no. Microservices architecture. It is not a programming language. It is not an API. Third party API. It is not the API. It is not a framework. It is not a programming language. And it is not there only for one technology. It is there for every technologies, every programming languages. It is a generic architectural design pattern. It will give you a architecture wherein option of developing an application in a different style. As a instead of one application, you can develop the application by dividing into multiple other applications. It is an architectural design pattern which will let you know how to design your application at the time of development. Fine. So it is not a language. It is not a framework. It is not a API or something. It is an architecture. Getting it? Which will help you to develop the entire application by achieving loose coupling into a different applications which can be deployed in different units. Example, most of the banking application follows microservices. Most of the tourism applications, Make My Trip, whether booking.com, Agoda, all these are there. No, all of them are, most of them are following microservice architecture. That means all the functionalities, flight booking functionalities, they have not developed flight booking, hotel booking, cab booking, all of them as one application. No, they have divided that entire application into different application. For you as a end user, as a direct user of the application, will you bother, guys, behind the scene whether they have written multiple applications or whether they have written a single applications? Will you bother? Do you even think of it? You are like, for you it is one Make My Trip application. For you it is one booking.com application, which has so many things available in front of you. Behind the scene, whether they have followed monolith, that means whether they have developed entire functionalities as a one application, or they have developed the entire functionalities into different applications, different independent applications. There is a separate application, separate team only for flight booking part. There is a separate team only for the hotel booking part. You're getting it? And those could be developed in same language or different language. Those have been deployed into different servers also. But very often we go with single stack. But if needed, that can also be possible. Fine. It is like, guys, multiple REST APIs. Microservices means instead of one entire REST API, it is divided into multiple REST APIs. That means multiple backend applications. And all those applications are deployed into different servers. So that if something went wrong in the flight booking, you will not be notifying your end users that entire application is down. You can just say that only the flight booking part for some time is not available. Why? Because you are going to redeploy that part only. You are redeploying only that application behind the scene. Are you all getting it, everyone? Yes, no, maybe. So very important key points about what we have discussed, I'm going to add here, which will summarize with something very important before we move towards the advantages. And have you also heard, guys, that these companies, there might be use cases, you might have seen articles on this, that this company is getting back to monolith architecture from the microservices. Why we switched to monolith back? Why we went back to monolith? Have you come across something as such? That means if there are something good you're learning about microservices, there will be some disadvantages also here. It's not like there are some problems here. Oh, the solution is only this and this is only best. No, that's not, you cannot be biased that this is only good. That's not the case. Just to read out this point, guys, microservices is not a programming language or a framework or an API. Microservices is in the architectural design pattern. It suggests developing an application by breaking down into functionalities, into loosely coupled independent deployable units. Independent deployable units referring to independent REST APIs. Independent applications that will be deployed into different servers. Instead of single monolith application, a microservice architecture uses multiple REST APIs, where each REST API is considered as one microservice. Multiple REST APIs means multiple applications, multiple services. Micro means multiple small services. Fine. And microservices can be used by any programming language or technology, not just Java. This is not specific to Java Spring Boot. It is independent architectural design pattern, as I have told you. Making it. Now guys, what are the advantages here? As on the key points only you can identify. The first is loose coupling. Microservices are independent of each other, which will help you to modify or replace anything if needed immediately only. Easy to maintain because each service is considered as is REST API, which is considered as is microservice. That is like a different application, which will help you to maintain easily. If there is something problem in the flight booking part, then it is not whole application wherein you have to look out. If it is a monolith, right, there is a high possibility that the flight booking is affected because of the tight coupling with the other services. All of them services are built as a one application, means if there is any problem in one particular feature, it may not be that feature may not be the reason. Sometimes because of tight coupling, so many things in one place, there is a high possibility that something else is creating the problem because of which flight booking is getting affected. But in microservice, like this will not happen. In the microservice, the things will be totally different. If something problem in the flight booking, all of the services will not be a problematic. That means because they have been deployed differently in the different servers also. They have different databases. Here it is like, okay, flight booking particular microservice is only creating the problem. That particular REST API is only creating the problem. So you'll go there and you can easily maintain and manage the application. Faster development. You're focusing on a small piece. Other team is focusing on a small piece. Very fast to develop. You have a big picture. Quick redeployment if there is any problem. Faster releases. If you want to add new features, it's easy to add because the others will not be dependent on each other. Less downtime. If something goes wrong, only that one particular feature you are redeploying. That means small feature redeployment, the downtime will be less. If it is a bigger application, if you're redeploying, sometimes it takes 1 hour to deploy the application. If it is smaller chunk, one small microservice, smaller time to redeploy, right? And different microservices can have a different technologies. It's not like every microservice of the same application should be using same technology. One, maybe you're using different technology. Other feature, you're using different technology. That can be possible. Easy to find the defect. Yes. So many benefits are there. When you talk about microservice, let me just add those. You can keep on listing. You can have a debate also on this. Advantages. The pros of the developing the application as a microservice application. Modular and organized. Language and platform independent. Wonderful answers. All of them are correct. Okay. See here. All these points hold good here. Microservices are independent of each other, making it easy to modify or replace. Each service can be managed separately. Development teams can work on different services simultaneously. Services can be deployed independently. New features can be rolled out faster. Service failure do not affect the entire system. Single point of failure will not be there here. Different services can be deployed using the different technologies. Making it. Now, what are the consequences of microservices? What are the cons? What are the disadvantages? Why? What made so many companies to switch back to monolith architecture? See, we came to microservice because we found some problem here. We found some disadvantage here. And alongside the disadvantages was there in the monolith, we could able to find some benefits of microservices. Considering these benefits of microservices, we came to microservices. Now, what are the problems? What are the problems? Why people have moved? Which complexity? You are right. Multiple services may complicate the entire system's structure. Suresh. That's correct. Not deployment. So many services, right? The structure of the application might not be so friendly. Latencies, yes, that's where Kafka and other things are used. But yeah, high possibility of latency. If one microservice is communicating with other microservices, in that case, a high possibility of latency, higher number of resources needed. First challenge, guys, first challenge is in monolith. If you have a requirement in front of you, you are developing as one functionality, right? You'll jump into it, you'll not think much of it, because all the functionalities you have decided to develop as one application. There is nothing to think about it. It's one application. It's a tourist application. Start working on it. Microservice means at the start itself, at the architectural designing level itself, to decide how many microservices must be there in this entire project, that itself is a very challenging. The first step itself is very challenging. That for this application, how many microservices should we decide, so that in future we can maintain it easily with less dependency among each other. That is also a great answer, Chavan. Are you getting it, guys? Everyone? The first problem is what? Deciding that how many microservices for this application. It's a great challenge. In the future, you cannot undo the things if you have decided. Second thing, since there are so many microservices, instead of one application, it is like so many REST APIs. So many REST APIs means so many microservices. So many microservices means so many applications. Don't you think the configurations files will be more? Lot of configurations and management. Because every application will have its own configuration. Overall configurations will increase. Third thing, the visibility of the application will be very hard. Everyone will not have a big picture or great visibility of the entire application. You will not get the clarities. Because so many microservices, so many different applications, the visibility is not so friendly. You will not be able to easily understand the entire ecosystem. Sometimes you will be involved in a project in some microservice part, in that some small feature you are developing. Entire team is developing one microservice. 4 or 5 developers is developing one microservice. In that you are developing one small part. And the whole of the application, you don't even have a visibility. What is happening there? Yeah. And since you have multiple services, the entire system structure will be very complicated. So many services are there. So that may also one of the disadvantages which are associated with the microservices. Let me add this. It could be many more than this, what I am listing out. Some of them I have listed out, which is very common. To start with the very first point, bounded context. Bounded context means deciding how to divide the system into multiple microservices. How many microservices are needed? How many REST APIs you have to create? It's very, very challenging. Which technology you want to use for which microservice? Since it is developed as multiple applications, multiple configuration files, a lot of configuration will be there here. There is also one of the problem and challenge here. And the visibility, of course, all the developers will not have entire visibility of the applications. You may not be aware that what is happening only. Okay. So like this, there could be other disadvantages also, because of which, again, you can move back to monolith. So if there is something good in some other feature, it's not like whatever you are already using is bad. That's not the case. Okay. There are something good in the monolith also. There are something good in the microservice also. There are something good with the microservices which may not be good in the monolith pattern. So it depends. You cannot decide that which architecture you have to follow. Okay. So based on this, you have to just follow, and you have to develop that's which is good for the application. Maintenance cost is there, which is very, very important. Whenever applications at the architectural level, you decide that you have to develop the application, many things you consider: the cost, the resources, how to maintain, how to have multiple servers, how to scale, what is the planning of scaling. Directly, randomly, you cannot just sit and decide that these many microservices, let's start to develop. No. If we divide this application into these many microservices, what stacks and technologies we are going to use for which technology, servers, how many resources are needed, how are we going to maintain these applications, right? How to scale, are there any dependencies between multiple microservices, about the latency issues. So many things will be decided, and then you'll make a decision that whether you want to develop the application as a one application, or you want to develop the application as into multiple services. Making it, guys? Have you all got one small big picture about it? Yes, no, maybe? Great. So my dear friends, now we need to understand about important components which comes under the umbrella of microservices. What are those? API gateway, service registry, admin server, Zipkin server, cloud config, ping client, Apache Kafka, Redis server. All these things practically we have to see by developing the code. And if you say that I am aware of all these things, then well and good, you know how to develop the applications. Fine. Now, one more important point here is that there is no specific architecture for microservice. That is not like every application may not have Zipkin server. Every application may not have admin server. Every application Kafka may not be used. Every application Redis might not be used. Every application cloud config server might not be used. Every application they may not use the circuit breaker pattern. They may not implement. All these terminologies are associated to microservice. And whatever architecture I am going to write here, that how the applications are built with microservice, by considering all these parameters, this architecture, it's not like that every time you develop the application, these things must be there. There is no fixed architecture here. There is no fixed things. Are you all there, everyone? All the possibilities I am writing here. That's it. That generally, these things might be there in general. Possibilities is what I'm looking here. Yeah. But all of them will have a single UI. All the microservices will be connected to single UI. We will not have multiple UIs also. Only backend. If I'm telling that multiple backend applications, multiple REST APIs, that is only with respect to the backend. Okay. One generic architecture I would like to draw, guys. It may not be that it is the case. So first only I've given you the disclaimer. Then don't try to have a debate that this is the case. Okay. First of all, we'll have a backend applications, guys. Will we have one applications or multiple applications, guys? Multiple, right? It is like REST API number 1. REST API number 2. API 3. API 4. API 5. API 6. That means multiple. One REST API is one microservice. That means one application is one microservice here. This is one microservice. Microservices, that means multiple APIs, multiple REST APIs. That's the meaning of it. This is also one microservice. Getting it? Once you develop any service here, any application must and should, this APIs, this application, you have to register. Where you have to register, if you ask me, you have to register with Service registry. Service registry. Every time you develop one service, one microservice, you have to register that microservice in the service registry. For the Spring Boot backend applications, we use Eureka server as the service registry. Eureka server as the service registry. Each components will understand here. All the microservice may also have admin server. All the actuators endpoints in one place. I'll talk about everything, all these important key points, guys. All of them may also use Zipkin server to monitor the performance. Each microservice is taking how much time, latencies, what is happening, how it is getting executed. To separate the application.yaml files, property files, we might use Spring Cloud config server. The configurations files in the actual application, to separate them, config server is being used. To process the real-time data transform, the real-time data processing, we might use Kafka. Right? We might use the cache, which is Redis, to have a static information, static data. All the static table data can be maintained in the Redis cache. One microservice to seek help of one more microservice. Guys, one REST API to talk to one more REST API. What are the two components we have used earlier in our RESTful services? REST template and web client, right? But in the REST template and web client, in both the places, don't you think we have used the full URL alongside the IP address of a server where the other service is deployed, the port number also? That is not good. If you want to scale up, if you want to scale up your application, you cannot mention that. In place of that, we use here something called as Fing client. In the Fing client, you will not be mentioning the IP address or port number of this application. Rather, it will go to the service registry. In service registry, all the application will be registered, right? They will be having one name to each application. So whatever names are there in the service registry, that name we will be giving to it. Will not be telling where it is deployed, what is the server, what is the port number, nothing. We just give the name which is available in the service registry. Fing client is used there. And each of this application may have its own database. All of them might have deployed in its own server. It's not compulsory that all these applications will be available in same server. You have deployed in a different server, and it may have its own database. You have deployed in a different database. It may have its own database. You have developed and deployed in its own server with own database, own server with own database. Are you getting it? The entry point of the application, we use something called as API gateway. API gateway, where the logic of filter, routing, and all of them will have one common UI, guys, or user will click. User don't know in the backend what is there. What exactly happens is user will click on flight booking. That will, the entry point of the entire backend application is the API gateway. The entry point, the API gateway also will be registered in the service registry. The entry point is API gateway. It will come to API gateway. Based on the request, API gateway will go to service registry, will check how many services are there, will take that information And API gateway only the routing logic will be present. Oh, this is the flight booking request. And API gateway, from here only the routing to the flight booking API will happen based on the information available on the service registry, that the flight booking API, the REST API flight booking is available on which server, where it is located. It will redirect, it will route. The logic of routing is present in the API gateway. The Spring security logic, the filtration logic, all of that will be present in the API gateway only. Okay. API gateway is the entry point for your entire backend application if you're following the microservice architecture. And the circuit breaker pattern, everything is implemented at this level itself. Fine. So this is the general architecture of microservices. Now, is it like, guys, every application will have a config server? Every application must use Kafka server. Everything must use Redis cache. Everything should have Zipkin server, admin server. All these components, are they compulsory components or subjective, guys? Are they compulsory components of microservice architecture? No, they are not. What is compulsorily available in the microservice, if you ask me? Service registry, API gateway. These two things will be available in every microservice. Apart from these two things, other things are based on the need. It's not like every microservice every application which is following microservice architecture may have these components. Nothing as such. Understanding, guys? Everyone in the class? Yes, depends on the complexity, depends on many things. Now, guys, one by one, let's try to understand here. Number one is service registry. What did I say, guys, about the service registry? All your APIs must be registered where? Can I say, guys, can I say that it is acting like a database that keeps track of all the available services in the system? Even the API gateway also will be registered. That means if someone wants to know about the services, they will go to this registry service to check how many services are there. So basically, it registers each service which is available in your system. Each service, which will allow, if you want to know about how many microservices are there, you have to go to service registry, allowing the discovery. All the available services are there. That not just that, where it is deployed, whether how many servers one service is deployed. Getting it? That is number of instances also. Number of instances means how many times this application has been deployed, how many servers one application has been deployed, that many instances will be available. If one application is deployed into 10 servers, 10 instances of that application will be available. And Eureka server is commonly used as service registry. Guys, what happens is, in the AWS, in upcoming DevOps course, in the AWS, I'm going to talk about the auto scaling. Very, very important topic. Suppose, guys, you have deployed one application in one server. If at a time 100 people comes into the application, no problem. That means to that one server means it's also a system, right? Where 100 people are coming into the application at once, concurrent 100 users. Maybe in the entire day, my application had 10,000 visits. But those 10,000 visits are not concurrent visits. They have come in different occasions. Imagine at one go, there are 1 lakh people coming into my application. Then the server will break down. The entire application will crash. Server only will crash. That's where the concept of load balancing is coming into picture. Exactly, Chavan. That's where what comes into picture, guys? Load balancing. So in that case, what happens is you are going to deploy your application into different servers. Maybe at first only you have predicted that I'm going to go live on my application. It is such application where the live broadcasting will happen. It's a broadcasting application where there is a high possibility that at a time 1 lakh users might come. I have decided, I have bought so many servers. I have bought some 20 servers. First itself, I have purchased, and my application I have divided into 20 servers. If I have I have deployed my application to 20 servers, it is referring to 20 instances of your application. 20 instances of your application. Yeah, that could also be one of the example. So if I am telling here that available number of instances, that means one application where it is deployed and how many instances in the instance, how many servers have been used behind the scene. Are you getting it? 20 instances of an application means 20 servers your application is deployed into. Are you there, guys? That means you are dividing the load of the traffic into multiple servers by using the round robin technique. What is round robin technique, if you ask me? Ribbon is used for that. Suppose I have divided my application to 5 servers. First request will automatically be redirected to this. That means this is the first instance. That means it is a different server. One application only deployed into different servers. Second request will automatically redirect it to this server. Third request is here. Fourth is here. Fifth is here. Sixth is here. Seventh is here. Eighth, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Round robin technique. Are you getting it, guys? Everyone? That's how, if there are 20 requests at a time, the 20 requests will be divided into different servers. So will there be an issue? No issue. Suppose, guys, you have predicted that a big movie superstar is going live in your application, and or maybe a big sale is there. Maybe a big billion day is there. A big sale. There is a high possibility the sale is only for 30 minutes or 1 hour. High possibility that 1 crore people might get into your application at one go. Can you deploy your application in one server? No. What you will be doing it? You will be deploying your application into multiple servers. And you have predicted that at a time 1 crore people might come to your application, and you have decided that I will buy somewhere around 100 servers, and I will divide my application into, I'll deploy my application into 100 servers. That means how many instances of your applications are available, guys? I want you to know instances means what? 100 instances of your application. Getting it? Will Eureka server know that how many instances of application is there? Will Eureka server maintain this information? Yes, Rajat. Yes, Madhu. Yes, it will maintain. That is what I have written here. What did I write, guys? Service history part, it registers each service, allowing them to discover the available services and the number of instances. Because they'll ask this in the interview. Are you all there? Everyone. How many 100 instances, and how many came up, how many turn out. I thought it's a really good sales deal. I was so confident that 1 crore people at a time will visit. I have already spent lakhs of crores of rupees and have bought 100 servers, deployed the applications, 100 instances. Only 1 lakh turned out. How many turned out? 1 lakh. To manage 1 lakh, 10 servers were sufficient. Don't you think 90 servers cost is gone, guys? It's a loss, a big loss. Are you getting it, guys? Big loss to me. Because I have bought 100 servers, but only 1 lakh came. I thought 1 crore will come. 1 lakh came. To manage 1 lakh, 10 servers are sufficient. But 100 I have bought, loss here. For this only, automatic scaling comes into picture. Auto scaling. That's where cloud comes into picture. Don't buy the server manually. Buy servers on the cloud. And there is something called as pay as you go model, as Rajat says. In the AWS, we have an option of AWS, all the cloud service, we have an option of auto scaling. That means automatically, as the number of users increase, automatically the servers also will be increased. Your application will be deployed into multiple servers automatically. Automatic scaling. You need not to pay. How much ever users came, that many servers will be used to run your application smoothly, and only that much you have to pay. Isn't it a very easy model, guys, which will be very cost effective? First only you need not to decide. You thought 1 crore came, 10 crore came, no problem. Your application is smooth. Automatically it will be used. Multiple servers will be used. Multiple instances of your application will be created. If 1 lakh came, no problem. Less services. You pay how much servers you have used, only that much. You need not to pay so much in advance. Getting it? So this is about the load balancing. By default, it is implemented. I will practically also show load balancing in our applications going forward. But now, how many instances are there? That also will be maintained by Eureka server. Are you getting that term here? Number of instances, everyone? Yes, no, maybe? Now, API gateway. One more important term. API gateway. It is the entry point for your application. Anyone making request, the request, will it go to directly service or will it come to the API gateway, guys? It will come to API gateway. The routing will happen based on the endpoint from the API gateway itself. Getting it, everyone? All of you present in the class. All the authentication, security, logging, security, everything can be maintained inside the API gateway. The filter logic, as I have told. Okay. So let me just write down here some important key points. Now, guys, API gateway will get the information about all the microservices from which component of your application. Which component of an application? Service registry, Eureka server. That means API gateway must be registered in the Eureka server. Agree? Yes, no, maybe? It acts like a central point to manage and route requests to appropriate backend services. That means it actually handles the request from different users and forward them to the correct backend service, correct microservice, correct REST API. All this part will be taken care by microservices. Getting it? And for the Spring backend application, there are many API gateways, guys. From the Google also, many companies are there. in your backend application also, you can use any of the gateway API gateways. Paid are there, free are there. But as a Spring Boot developer, there is a free API gateway, which is Spring Cloud Gateway, which is commonly used for the Spring based applications. It need not to be only this. The API gateway, there are many other API gateways also which you can implement. But as a Spring Boot developer, very common we use Spring Cloud API gateway for our Spring based applications. Got it? Now coming to the next important component, admin server. Guys, is it like every application will have an admin server? No, right? All of you know the concept of actuators, guys. If you want to monitor and manage your application in the production, which concept comes into picture? Actuators, right? Which gives you predefined endpoints, which will help you to monitor about the health matrices and other things. Suppose if there are 10 backend microservices, in all the 10 microservices, you have to implement actuators. Admin server will act like one central repo for all the endpoints of your application, all the actuators endpoints of your application. There are 20 microservices, that means 20 RESTful services. And all 20 RESTful services, all the actuators will be managed in one place. What is that one place name? Admin server. Getting it, guys? What is admin server? It will maintain the actuator endpoints of all your backend services. Who will maintain the actuator endpoints of all your backend applications, which will help you to monitor and manage your application? Admin server. Done? All of you, I will practically show you how the things are working here. But to start the journey, a big picture, I hope it is getting clear about each component. Now, to know the performance of your application, to track how the application is, one microservice is using one more microservice. If someone is making a request, that request coming to which microservice, which endpoint, how much time it is taking to respond back, and that microservice, is it taking help of one more microservice or not? All this distributed tracing, if you want to know what comes into picture, Zipkin server comes into picture. Zipkin server comes into picture. It will help you to know the performance of your application, that what is happening. One microservice is taking how much time to respond back. Where is the control currently? All these things can be managed using the Zipkin server. Getting it, everyone? All of you present in the class? Yes, no, maybe. Guys, all the loggings, authentication, authorization, all these things will be implemented where? At what level in the microservice? This is also interview asked question. API gateway level. Okay, that key point is very, very important key point, which I have forgot to add. Okay, this is very, very important part. Okay, let me just take this here. I'll go back and I will add, because API gateway is something which is common and they'll ask more questions on this in the interview also. The primary responsibility of API gateway is routing and filtering, guys. Includes two things. Number one is routing. Number two is filtering. Routing we have seen. This is the routing. Above whatever key points are there, about the routing they are, right? So routing is what we have written already. And we have one more important component, as I have told you, which is about the filters. Routing is there, filter is there. Okay, which includes many things. Some of the things are loggings, authentications, and authorizations. All this logic will be implemented here itself. Getting it, everyone? So this filtering logic is also important. At what level the Spring security will be used in the microservice, they will ask in the interview. What is your answer on this? Getting it? Everyone in the class? So this is about the API gateway, which is very, 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 very crucial. And for the API gateway, guys, we use the cloud gateway, which is latest under the family of Spring Cloud. Earlier, we used to use something called a Zool proxy. Have you heard about the Zool? You might have heard if you are into microservice earlier at least once, or maybe if you have tried to learn. Latest Spring Boot versions will not support Zool. It is outdated in the Spring Boot. Earlier, it used to get used as a API gateway. To create a API gateway, Zool used to get used. But right now in the latest Spring Boot version, Zool, we don't have any support. We have to go with the cloud gateway itself. Okay. Zool proxy is no more supported in any of the Spring Boot versions. Because whenever we hear any of the, if you ask any of the senior Java developer, Spring Boot developer, what is being used for the API gateway creation, the answer is Zool. And it is like it used to be a requirement of a job description if they are seeking a microservice developer, that you should know about the Zool proxy. But right now Zool proxy is not being supported by the Spring Boot. It is outdated. Till Spring Boot 2.7 it supports, but Spring Boot 3 onwards, Spring Framework 6 onwards, there is no support for Zool. You cannot use Zool as a API gateway. Is that fine? Everyone in the class? All of you? And this is very, very important note, guys, because if you ask someone that I'm learning microservice and if you say that I don't know Zool, they may argue with you what you know. So this important point is very, very needed. Okay. Zool proxy is no longer supported by the latest versions of Spring Boot. In fact, earlier, when I have studied the journey of teaching Spring Boot and microservices with Naveen sir, in 2021-22 batch microservice, 2-3 years back, when I used to teach microservice, I used to discuss Zool proxy there. And one batch when I have used in place of 2.7, I have started to use Spring Boot 3. The moment I started to use Spring Boot 3, 2 years back itself, Zool proxy is not even there. And I had not done some work on this. I was like, as I've done so far for longer time, let me go with this. It was not there. Then I realized it is no longer supported for the latest, and it is official that it is outdated now. We are not going to use. What are we going to use? Spring Cloud Gateway. Its own gateway is there, which is being used to create the API gateways. Is that also fine, guys, every one of you? Yes? Guys, where do we maintain the database connection, server configurations, Kafka configuration? All these things we maintain inside which file, guys, in our REST API application? Where do we maintain about all this information? Data source, application.properties or application.yaml file, correct? To separate this configuration file, application.yaml or properties file from the actual backend application, we use one more important component. Which is that component, if you ask me? That's where the cloud config server comes into picture. Cloud config server comes into picture, which will help us to keep the configuration service, configuration files away from the actual file. And the interesting part here is, if there are any changes you have to make in the application.properties or YAML file, you need not to repackage or redeploy your application, because they will be kept in separate repositories, separate servers or repositories. Maybe you are maintaining that in the GitHub repository, and your application will be connected to GitHub repository. Anytime you want to make changes in the application.properties because of change in database or anything, you need not to redeploy your application. You need not to repackage your application. Spring Cloud Config Server will help you to separate these files with your actual backend application and keep this file in some isolated repositories. And if you make any changes here, that will not be affected. All of you? Yes, no, maybe? So this is very, very important feature about the cloud config server. You must know as a microservice developer. If you say I know microservice, you must know about it. Done, dear friends? And I will also practically show you that how I'm going to manage this part. If you know these things, you can say I know the microservices. Okay, I'll do one thing. I will take this. I will add it separately so that these points are not mismanaged. Everyone? Now coming to the Redis and Kafka, is it compulsory that every microservice you should use this concept, guys? Is it compulsory? No, right? But can we have that? Yes. The role of the Kafka can be very, very significant for the real-time data transformation. Okay. Real-time data in the sense, guys, real-time data I'm referring to, guys, for the share market in India, you might use 5paisa, you might use angel broking, you might use Share Khan. Like this, multiple platform brokers are there, correct? Yes, no? Now, are they the one who's actually maintaining the share market? Are they the one? No, right? Whatever real time is happening, immediately the data has to be transferred. Imagine, guys, the market, what is happening in the market and whatever application which you are going to use. If there is a latency of at least 10 seconds also, there is a possibility of lakhs of rupees loss. High possibility is there, right? Then in that case, do you think the data has to be given to you with lowest possible latency? That's where the Kafka comes into picture. Real time is, that is a real time. Score, guys. Right now, all of you might be watching the border Gavaskar trophy, cricket trophy between India and Australia. Are you in Australia right now? No, right? Are you able to know that what is the score there? There also real-time data streaming platform. Streaming platform is also one of the example. Between multiple microservices, if you want to transfer the data, what is being used? Kafka is being used. Yes. All of you present in the class. Like Kafka, there are other things also, but this is one of the popular one. Okay, ideal for the real-time data streaming. And Redis is not like compulsory, it is an in-memory data that stores caching. That means such data which is common for all the end users, all the clients. For every time going to database will not be sufficient, no, not be good. For a static data, a common data for every user. Every time they're making requests going to database, number of DB calls, number of DB hits will be more. To avoid the number of DB hits, we have something called as Redis server, and that is where the Redis cache comes into picture. And that is also very, very subjective. All right. So this is the big picture of the microservices which we have discussed for today, guys. What we are going to learn, and as a microservice developer, what you should be knowing minimum. Is that clear to everyone? All of you? So from the upcoming class, can we start developing the applications and all the terms which you can see on your screen, guys? Everything I will discuss. And again, it is also a very vast subject that you can discuss for 1 or 2 months also. Every technology which you are discussing can be discussed for years also if you have a plan to discuss. But that is not the motive here. We should have a big picture. We should know how what things works within the limited time we have. But everything must be knowing. Like as a microservice developer, you should have a big clarity of all the terms and things which we have discussed. It should summarize that yes, in the very first class we have discussed this, and at the end of the last class you should say that whatever we have discussed, we have done that, we have seen that, and that is the end of our entire course. Great. So thank you so much, guys, for joining me in today's class. We shall meet tomorrow exactly at 7 a.m. and start the journey of coding with microservices. Fine. So let me just share this file with you. Microservices key points and notes class 01. Okay. I would like to go back to you will have a separate video on the cloud deployment, which is recorded by Naveen sir. Anil. I think the Friday's class has not been added to the dashboard. It is added. It might be available in the other, guys, Friday, what is the topic I have discussed for a weekday batch? Yeah, it is there in the data JPA part because multi-DB configuration I have discussed. Multi-DB, it is available in the this thing, a data JPA folder. Okay. That project groups are not active, Javeria, so avoid it. We had initiated, but not everyone is serious there. So what we can do about it? Except a few people. And it's so happening that most of them are just making 1 or 2 to work and they just want some projects, right? That recording also will be uploaded. Okay, Saiji. Uday Bhanu, the key points have not yet added. It will be added after every module. But all the code files in that particular class and board work has been already attached. The board work and the code files will be available in the same topic which has been covered. And the key points I have started to update from today. Microservices I'll give you now itself, but others I'll upload as a separate. Okay. That videos are there. That will be uploaded by Naveen sir. I will add that. Okay. The links I will share, and apart from that, there is one more project which I'll be showing with you. Okay. Akash. That is Spring Security filters are being used, Akash. In that videos, it might be there microservice. If not, one more project is there. I will show you. Okay. It's a security part. That is one of the annotation. Maybe to just create the enums of your own. I have not used that in any of my applications. Let me just cross check if even if I have used. Hmm. To create the enums in the JPA world. That's it. It's the concept of enums. Okay, human readable, maintainable. That's there. But what is the summary? Okay, okay. No, will be filled to store it as the string as the value. Hmm. As the string value of the enum used in, for example, this is the status. All right, all right, all right. As Anil says, it is used to map the Java to the database enum. In the database, there might be an enum wherein there might be one column. That example, there is a column called a status, whether it is active, inactive, pending, and that you have to map as a string. That's where the you know the enumerated annotation is being used. It is about the enums. Okay, like this there are so many specific annotations which are used for some specific purposes that as a developer you might not use in your day in and day life. Okay, they'll be very specific to the use cases. When you are using that, you just try to learn what exactly they are. We are developing many projects, Akash. Example, Telesco will have its own quiz project. If you could remember, we used to play one Menti game. Now, like the similar, we have a Telesco's product. Telesco is coming up with its own products also. Our backend team is working on our own products. We have enough of developers. If there are any space, I'll definitely let you know on this. That we have to configure, Madhu. Some extra configurations are needed. That's it. But if there is any space, I'll let you know, Akash. I'll just try to talk, and if there is any possibility, I'll definitely let you know on this. And coming to the Madan question, it is like some configuration code you have to write, some extra configurations. There will be some key values. There will be something in the application.properties file in the Java code. You can do that by configuring. Just add, if you could remember, I had added one property there in the application.properties, spring.bash.initialize schema always. Have you added that? Spring.bash.initialize underscore, hyphen schema always. Oh, you have done that, huh? If not, you have to create a separate table or some other configurations. It should automatically create. Uh, if not, you have to do the configuration, separate configuration. Batch processing configuration separately, you have to do it. Enable. We have some annotations called as enable batch processing and some code if it is required. Which file? Which file you're talking, Madan? Clearing my batch config file to check. You want me to just have a look on this? All right, guys, thank you for being with me in today's class. You can add, but when you're adding, you have to also check about the dependencies and if other microservices will be affected, whether you want to scale, is there any way that you can enable the other microservices to communicate with it? So many things you have to consider. So you can definitely add. There is no issues in that. But to decide that how many microservices are there, how to enable communication between each other, will there be any dependencies between each microservices, how to read the routing logic, all these things is little complex. All right, guys, tomorrow exactly 7 a.m. we shall continue the journey of microservices. Make sure all of you are there on time for the upcoming interesting classes to cover all the things which we have discussed in today's class. Thank you, every one of you.